So yeah, since we have finished the lecture, my idea is to now start working on the parser, and basically I'm gonna try the same strategy as looking at my old C code and try to create a class called Parser probably, and that should have this kind of structure with the node, the I guess expression types, and we'll try to build this kind of tree but using classes instead. Let's see. So we need, first of all, probably we need a program node, right? So class program node. This is the main thing that we are gonna need, and it contains the classes. First, let's try to see how the parser structure will look like. So class parser, this one should have obviously a constructor and probably also a parser run or something. Okay, the question is, what is this going to initialize? Well, I think we need to pass in a list of tokens. So tokens is going to be a list, and I like to use this kind of comment to indicate the type of the list, because the list is generic, or I guess it's not necessarily generic, but it contains objects, and I like to specify the type of the list using a comment. We define the attribute like this, and then we can just say tokens is equal to these. You cannot really name if I were to name here the variable tokens, it would shadow the attribute, so I have to do it like this. Okay, and as I said, now we need a run function, which is going to give us a program node. Basically, that's what it should return. So yeah, we are going to initialize a parser with some tokens, and then run that parser and get back the program node. Okay, so that's one thing. Then we also have this parser prints the util function, which takes in a program node, but this is going to be on the nodes themselves. So yeah, like we are going to need a print or toString method. Probably I'll override the toString method, because if we look at the, actually let me harpoon these two files. I need to get in the habit of using harpoon more, I guess. So if I look at the prelude, we see that the object class has this toString method on it, so we can overwrite it and make it do whatever we need to do. Okay, so I guess we should implement these two functions, current and advance, on our parser, which are gonna handle the tokens list basically. So this should be kind of private functions, but you cannot really have private functions, so we can just imagine. So advance is just gonna do something like tokens is equal to tokens dot next, and then return self. So what we need to do is, if we take a look at list, we can access the value using the value function. So something like tokens.value, this is the head of the list. So we can have a case, maybe. No, I guess a case makes sense, and this thing should be like case t token, then it's gonna be t, Okay, and I mean just this. Anything else would be an error, I guess. So might as well just have a single branch in the pattern match. Okay, so these should be the two helper functions that I need. Now sure, this one I don't know, but you can see that here we do current and then we advance, so that's why I would need these two. And maybe this can be object, and you know, we have only this as the bodies of the functions. Okay, so let's try to do build program. But as you can see, for build program we also need the class node, and the program node has classes, which is a list of class node. And sure, we need an init, self type. This is more or less the program node. Okay, but in here I have this build program method, so sure, why not? It's going to be build program, returns a program node, although it's like pretty useless to have a separate function. So I can try to do parser current initially, so let's have a let token is equal to current, and while this token is not end, sure, while I guess I can say not token equal to, so it's more or less case token off, and then we have, if it's token end, then we return false, so we stop, and if it's any other kind of token, we return true. Sec loop pull, right? And yeah, probably we'll need like a block in here. So yeah, basically if the token is token end, we are going to close. Alright, and the first step is to build class node. Alright, and I guess in here might even be easier to just build a list of classes, I guess. So might also need classes, so list class node, and I should be able to do something like classes dot append build class or something. I mean, I guess parse class. Let's say we parse class, append it, then we check for the current, So token is equal to current, and then we advance. And then we current it again. So here we expect semicolon. And what if I create a parser.cl? In which I just try to have something like program is going to be a program node, new parser init tokens parse program, right? And then I can just new io.out string program to string or something. Because that's basically what I needed. Okay. In the make file, so make compiler parser. Okay, so now it complains that we don't have a parse class, which is good because we don't have it. Parse class. Okay, so that's the first error. Oh, yeah, and at the end, after the while loop, sure, we should return the actual thing. So let me just do new program node dot init classes. So we return this thing. Okay, let's see if it compiles. 558. Oh, so parse class needs to do something. So new class node, for instance. Okay, and it looks like it actually compiled. Build. I mean, whatever. You know, we can run the lexer on these kind of files. So cat and we don't really have command line arguments, so we have to use it like this. And if we try to use the parser, what would happen? It just prints it like that. Okay, fair enough. Because, you know, we need to do something with the actual class. I guess, you know, easiest way to do this kind of thing is to go one by one through these. Right, and I guess the easiest for class is just really basic classes. So that's what we need to try and achieve. So here it's interesting because if we don't have semicolon, then we should exit with an error. But how can we do that since we don't have return in our language? Well, yeah, it should abort because it's not I don't even know why I put that, but and yeah, sure, here we could print some error message. Right? And yeah, that could make sense. So like parser show expected. Yeah. Huh. But for now, let's say that we only abort, we don't really show error messages. Okay. So I guess parse, or I guess build class, it's the next thing. This one, I remember it was quite straightforward. We have to check that we have a class, then it's like really linear in a way. So let's see. So we need this kind of construction again. So we need class. So here I do parser current again. Oh, but I could not use a let and just use the call to the function. So we look at current. Okay, and if it's a class, then it's fine. Otherwise, it's an error. So again, here I would abort from this one, and here, not important. So if it's not like this thing, then we just exit. Okay, then the next step is to add advance, sure. And now we need to get a class name. Now we need to take a class name. So yeah, somehow it looks like we cannot escape the let statement. So but at least the let is going to be like this. Wait, yeah. whatever, let's make it look a bit more like the one from here. So yeah, okay, whatever. So that's just like class name. So we might need something like cn, which is going to be token class name. And then we have something like token equal current if case token of class name. Let's see if this one is true. Else. So on the then case, we need to store this thing. So I could say just cn is equal to t. So we just cache the class name. And on the else case, we can just abort, because why not? Okay. Then we advance. Makes sense. And then we have this optional inherits. Then L brace and R brace. Okay. Interesting. So let's see what would happen if I say new io.out string cn.value. So we make it, wait, what? Oh, so value is optional. Yeah, sure, makes sense. So it's like maybe case of, so it's like sum, then we out string, then it like even what's inside of sum needs a case. So make a case on this thing dot value. It's like a string. Something like this should work. Okay, and at the end we need to do class node. Five, 7, 1. Wait, what? Oh. Okay, yeah, I mean, pretty weird what I did here. I should have done like case, and on this branch like this, and on the other branch I don't really care. So or I guess on the other branch is the abort. And maybe even better would be something like this, but I need to do a new class, token class name, and then abort. Yeah, so something like this. And even for this one I can do that. It can be something like, okay, if it's token class then I don't do anything, and if it's token T, I do abort. Maybe it's a bit cleaner. So the same thing for here. Right, it's a bit cleaner. Whatever, this one is just for debugging purposes, so type object, what? Oh, it should be like this. So it shows A because that's the first class, but yeah, then it fails, obviously. So as we see here, we need to try and parse L brace and then R brace. So we can copy this thing because this is the main thing that we do. So token L brace, so this is the opening, and anything else we just abort. And then we need R brace to make it stop. And we get A and B, so now we can see both classes. Sure, that's pretty cool, right? But yeah, now we need to also do the optional inherits. So for the optional inherits, we can still have a case inherits, right? So if we have inherits, then it looks like we advance. So it looks like we do something more here. Advance. Okay. All right, so we advance. Then sure, we need to do the class name again. So we could try this. So we take the current, we take class name again, and we advance. That's everything, but we need to say this class name is actually parent name or something, token class name, and yeah, in here we need to abort, but in here we could just return pn back, and we could say pn is equal to this thing. So this is just going to return back the same thing, which is going to be void, and in this case it's going to return the actual token. So that's my idea. Okay, and yeah, whatever, we'll need to do like a while loop inside of this one, but let's see if this compiles for the first case. Oh, so 582. Here it complains that it gets back an object. Oh, because here I should say pn, and here return pn. Huh. And I mean, it's not really that relevant to even do that. We can leave it like this, as this still makes sense. Okay, perfect. And we get AB. So everything is displayed correctly. Okay. But yeah, we need class node to have these two things. So we need, actually I'm really curious. Class node, when I defined it, it had name, superclass, attributes and methods. Okay. So it should be name, token class name, parent token class name, and the rest of the things we'll do them separately, but so cn and token class name, return self. Okay, so now we can actually do here like init cn pn. This one was a bit useful. Oh yeah, I remember why. Because string cannot be null, so yeah, whatever. Parser 01, and here we need parser. So just an easier way of doing that. 519. Okay. So now let's override toString for these things. toString prelude. So this is how toString looks like. Okay, so if I cat the ref is like program. So should be should be a let somewhere. And then maybe S is gonna be a string program, right? String program. Then we have in. And sure, here it should be an iterator like over that. So an iterator over the classes. So iterator over the classes. Obviously at some point we are gonna do classes equal to classes dot next. And the other thing should be case classes dot value of, and if it's a class node, then we should do cs dot concat c.toString is sac, and maybe s.concat new line or something. The only issue is that we also need to ident the thing. Or like indentation, right? So maybe we need a separate toString, which also takes in the indentation. So it's like here a number, indent, right? And usually if I were to call it here, I would say indent plus 2, for example. The only thing is that now we need a toString there for it to work. toString indent right. Let's say whatever, this one is just class. Okay, so now we have, okay, yeah, we need to call it something else then. To indent string, or I guess show or something, I don't know. Okay, but we need to actually return the string. Yeah. Whatever you say here, yeah, should do. Program no, because I have to call show in the parser. Show 0. Okay, interesting. So if I do new io.out string s or something, program. Hey yo, what the hell? Just thinking. New io.out string something. Let's see if it gets there at least. Doesn't even get there, what? So is it not a class now? But doesn't make sense. I mean, why would it? Segmentation fault. Because here I do like class node init, why not? And here I append parse class. Yeah, here like in the list, right? So list.cl. This one, you know, it gives you object. So maybe another thing I'm curious to see is classes value to string. So it doesn't like I do that. Let's module let's try to use the other allocator. Still doesn't work. Okay, what the actual hell? Parse class. I mean, this clearly happens, right? Cn case cn of, well, actually it's cn.value of. And what can we have here is the optional, right? So it's sum. So if it's sum, then we do s.value. And then I can say like case this thing, if it's a string, string s. So like A and B, that makes sense. Class name, parent name, returns self. What the actual fuck? Oh, but here I cannot really show it. I mean, I can try to do something. Though, I can just comment it out for the moment. And I maybe can do something like c dot show 0. So it actually shows something. What if I abort here? Okay, interesting. Okay, extremely weird though. So I'd have to show like class and then on the next line the name. So no, I want to do that, to be honest, just to have it at least. So if this one is sum, then I have s as value. So this one is like required to exist. There's no other option. Let name, or I guess let n is gonna be like this. I mean, that could work, I guess. Like we have the class name is equal to s. Sure, why not? Or maybe this one could just be an IO and it just prints. I guess, I don't know. Might as well. Repeat. That's funny. So yeah, I guess show it should just IO it out probably. So I can even just say it's object, this thing. Right, not really care about it, so it should be something like this. Right, S, and here I might just say new IO out string repeat indent, right, something like this. And I don't need that. Okay. Let's put here a new line. And here we can just show the thing. Well, here I meant program, like the string program. And here we can do like a new line. And then I don't care right now. Okay, so 539. I think I need a block. Five, 7, 3. Oh. Well, yeah, whatever. Oh, that's annoying. Even if it's like 0, it still does an ident. I have to fix that. Okay, so why does it show class program? That's weird. Oh, I guess, yeah, I know why. Oh, so it's less than or equal. So I think it should be less, like strictly less. Yeah, whatever. I'm curious, hopefully this doesn't really break a lot of stuff, right? So this should be potentially breaking the game, make game. Wait, what? I guess it's make example. So like the client is the only one that was listening to or like using that thing, right? So and it looks like it didn't break it, so fine. Okay, whatever. So interestingly enough, it got a save fault, huh? Oh, I think but I mean you cannot really do append if the list is empty, right? I don't remember exactly how it's done. So append, because I mean it's gonna be void, so I don't really care right now about that. But wait, where does the save fault happen and why? The hell? Let me just take this thing out. So here, and I'm really curious, how the hell? Oh, wait a second. Because I say new list here. Because you cannot really I don't think you can do append into an empty list. Yeah, so you kind of need here a new list. Kind of need a new list. Huh. Well then, I can say here classes dot next actually. just remove the first one, which is bugged. Okay, perfect. Because yeah, the first element of the list, it is what it is. I'm pretty sure I remember this kind of stuff. Where I initialize a list with like an object and I then use next, just because the first element is gonna be like the, let's say, first element. Okay, anyway. So here I put class, right? Okay, interesting. So the next thing that I need to print is the class name. So something like this, new IO, out string s, and let's see. Oh, and without let, it's just the case. Okay, nice, it's close. So here I just need to repeat it, indent +2 concat s. Yeah, now it's even closer. It's really scuffed how you have to whatever. Okay. And for the next one, this changes a bit, because we can have both sum or we can have none. But when we have none, I don't really care about it. Okay, and in this case, we actually have, we need to have a string. So it's something like this. Alright, so if the parent exists, then we need to have a string. Otherwise, I don't care. Okay, so 530. Oh shit. What? So parent value, if it is sum, we do something. If it's none, we don't do anything. That's really strange. So for class A, it doesn't even exist, so we should do on the none case. Should go on the none case. So here, for example, Pn remains, oh, it's void. Sorry, it should be Right here, parent is gonna be void. Oh, then it's the same thing as it is here, but it's like an extra if not is void parent, then right. And also here we need to do like this one is interesting. Concat everything from here, because we need to put like a new line in front. Okay, so now it looks good. Now it looks decent. All right. So that would be parsing the program node and class node. Extremely ugly, but it does the job, I guess. Okay, what's the second test? I'm curious. Okay, so this one introduces like attributes and stuff. So something changes here basically. So when we build a class and we get to rbrace, it should be like a while. It should be like a while loop. So I guess we already have an example. While case token t rbrace is false. Yeah, we do like build feature. Build feature. Sure. It's another thing is to check end. Check for end, I mean. Yeah, something like this. So if it's end, then abort, otherwise doesn't matter. Then build feature, we'll see about that. And then we need to read a semicolon. So semicolon was somewhere around here. So here should be like build feature and then semicolon, then current again. Okay, and at the end it's an advance. So I think that's how it looks like, right? We take the current, then we have a while it's not rbrace. We check for end, then we build feature, we do this thing, then current, and then advance. So So yeah, I think it looks good. It's interesting how build feature is gonna work. Oh shit, parser peak. Okay. Let's see if this thing still works for 01. Whew, still works. That's good. So for build feature, looks like we need peak. So let's go to our things. Let's try to see how peak was working. So peak will look one step ahead. I mean, I don't know what I was expecting. Case tokens next. No, sure. It's not the best way to do it. Because, you know, next could be null, so it is what it is, but so here we have to pick case peak off. Token colon. So if we find the colon, then usually this should be an attribute, and otherwise is going to be a method. So the token in this case is going to be a method, right? Looks like we need attributes, attribute, I think it's attribute node, yeah, must be a new list, as well as method node. Okay. So yeah, it's just like parse class here, but for this one is attributes append parse attribute. I don't think I need that. I need some methods parse method. Alright, this is how it should be, and I would say here attributes next, methods next. Okay, now class node. Let me just AS okay. And let me just also put them here. Okay, pretty cool. Now we'll need to update the show, but in a sec. We first need to implement these two methods, parse attribute and parse method. So parse attribute, let's say it returns object, parse returns like object again, just to make things compile, I guess. Yeah, so it compiled first try without an LSP, by the way. So yeah, we need these attribute node and method node now. Attribute node should have token ident, right? Should have token class name for the type, and then is gonna be an optional expression, but let's leave that out, right? It's, yeah, can be left out for the moment. So we are gonna have a name, token ident, and the type token class name, self type. Yeah, so this is attribute node, and then method node. So obviously it has a name, the return type, but I don't even think we need these right now, like the method, so might as well just leave it as it is. It's like method node. Okay. So we'll just leave it out for now, right? And parse attribute should return attribute node. That's right. So for the attribute, pretty simple. It needs to parse identifier, then colon, then class name. Jesus. So identifier, but this is like I would rather just copy this. It's easier. So we're gonna have the token, which is current. Then we need the token ident and the type. Pretty much that's it. So token ident. Okay, so I mean, no, class name, whatever. So first things first, I should do something like this for the name. So if we find token identifier, right, how can we, oh, I'm stupid, it's T basically, it's token ident, right? Pretty simple. Then, as I said, we need something like this for column, and then we need this exact thing for the type, right? And obviously at the end we return a new attribute node. We initialize it with the name and the type, like a class name. Perfect. So let's see. So this is the test case, right? First one doesn't work because I forgot probably a semicolon somewhere. 693. 6. Oh, I said 693. So I have an extra comma. Type object, so line 696. Wait, what? Oh, because here I need to say something like new token ident, just to satisfy that. Okay, interesting. Ooh. We have an abort from class Parser. I mean, obviously from class Parser. That's how it works. But I'm curious what the problem was. So if I try to lex it, right? What I'm doing here is search for identifier, then colon, and then class name. So I don't really see the issue. So where I'm doing parse attribute. I want to see something printed. So it prints it once. That means probably the error is inside of parsing a thing. Not really. But it cannot be at semicolon. It is at semicolon. What the fuck? So parse attribute. Am I right? I don't remember. After parse attribute, I was doing like assign. So build feature. Like it shouldn't. Be like what? Parse attribute. Oh, I forgot I don't have an LSP. So I advance, which makes sense. Right, it makes sense. Maybe it's not going in the right function, so maybe it's not coming here. Yeah, maybe peak is not right. Okay, so peak is not right because it goes in parse method instead of parse attribute. So token colon, am I right? So peak. So what is wrong with peak? Obviously I need to advance. Or do I need to advance? Yeah, I don't think I need to advance. Holy shit, it works. It just worked. I mean, we don't show the attribute yet, but we might as well. I don't even remember. Okay, so it shows each attribute. Okay. So that means that inside of the show for class we need to loop over the attributes. Like, that's obvious. And it's gonna be something like this. So we take this thing. So let's see again. So it's attribute on the same thing as the class. So it's like that. 3 attributes. Okay. So attribute node, and I show it with an ident of +2 basically. Yeah, sure, +2. Why not? And here it's attributes next. Okay, so now if I try to run this thing, it should say that show does not exist on attribute. That's right. That should be the only error. So now let's steal this thing and let's do it on attribute node. It should be indent. It's indented by 2. That's correct. Attribute. Bam. So then we show the name. It looks like we show the name. Identifier +2. That's right. And then we need to show the type, which will always exist. Not sure though. Oh. Type. Yeah, I guess it's the same thing. So almost. It was almost right. Almost right first try. So I guess I need to outstring a new line here, just for this one. Yo. That's insane. I'm not sure, is it? Do I need to show an extra new line, maybe? I can return IO for these functions. Maybe this is the only place where it kind of sucks. IO. Just to make it easier to chain them, something like that. Huh. Okay, and now if I do the diff, okay, sure, it has an extra new line at the end, whatever. Alright, so I mean, no, honestly, it feels much more difficult in this language than it was when using C for some reason. I mean, obviously there's no LSP, there's no showing the errors. It's much more, it has less features, I mean, harder to make errors, even though it's, you know, I mean, it's not garbage collected, but even though there's no memory allocations or anything, it's still much more difficult, like extremely difficult. Not sure why though. Because I mean, you know, it's like really Java-like. It's not. These things are a bit hard. Honestly, it's like the cases and everything. So the fact that you cannot cast makes things a bit trickier, and the fact that you have to use this case, that's the main thing that I find annoying. But at the same time, I mean, you know, if I use optional with some and none, obviously I need to use case at some point. But yeah, that's the only thing. The fact that here I need to do a case, like the fact that we don't have generics, maybe it's makes things a bit more difficult, because optional, for example, it uses object here. So to cast it back to string, even though we know it's a string there, we need to do a case. So that's the annoying part, I would say. But like other than that, it's not that difficult, because we just need to translate the C code into cool code pretty much. So it's nothing extremely fancy. So let's see if we can do the checker. So self-hosted parser, self-hosted parser analyzer. Okay. Because I think that the only thing that needs to change is this. So if I do checker, think it's checker st or something. Oh, syntax. Self-hosted parser. So I think the first two should pass, yeah. Man, but it's insanely hard. To make like real progress. So let's see. I mean, at least the methods we can do. Like, what's gonna be really hard is gonna be error handling, which I think I won't even do. I won't even try to do error handling. I'll try to go with the bare minimum of self-hosting the compiler, and that's it. Like, at least hello world, I mean. But yeah, like, if we are able to run the compiler on the compiler.cl file itself, that would be, I mean, that would be too much, honestly. Like, what do you even do after you do something like this? Like, basically you just finish the game, right? It's nothing left to do if you manage to finish a self-hosted compiler. But yeah, it's like going back to the tutorial zone after you finish the entire game. Like, there's no point in yeah. So method node, right? But I mean, even attribute node is not done yet. Yikes. Oh, so attribute init. Yikes. Man, but you know, it's not that bad though, if you think about it. Like initializing an attribute. We just need to see if we find an assign. So if we find an assign, then sure, it's oh my fucking, I remember the expression null. Jesus Christ. Holy shit, even external. Oh my god, that's insane. Yeah, like, I mean, I have to do external because otherwise it won't work. Okay, but I'm not sure if I already have extern here. Oh, I do. Then yeah, it shouldn't be that much of a pain. So then yeah, whatever. I'm curious on build expression how it's gonna be, but let's go ahead to program node. Where is the parsing? Parse program, parse class, parse attribute. Okay, here. So the next thing is to check. So obviously we take the current and we need to check the type if it's a sign. So it's gonna be something like this, probably. And here we are gonna have like an expression coming out from this thing, and it's gonna be like either expression external, either build expression or expression null, right? That's how it's gonna work. So if we find a sign, we need to do something different, and if we don't find a sign, then we don't do anything. So it can be just well, as I said, if we don't find the sign, it should be expression null. So we'll see how we do that though. we should have, I mean, obviously we'll need a class for expression. Jesus. So that makes sense. Parser.h. So we have now the method node, class node, program node. I think we'll need expression node in some way. So class expression node. I mean expert node, sure. But the expression node is just the parent. So the rest of these things are gonna be children of that class. So expression null, for example, or expression external. I'm not sure what the main class is gonna have, but I think expert null inherits expression node. Like this should be a thing. Expression extern. Wait, is it external or external? Wait, what? Huh. Wait, why is oh, yeah, because I didn't really need anything from it, but yeah, whatever. And the other thing will be something else. So yeah, for now this is enough. So expert is gonna be like an expression. Let's edit it. Expert node, right? And as I said, when we have something else than an assign, we need to do expression null. That's the thing, and we don't have to. So expression null. And when we have an assign, well, I guess no expression null. And when we have an assign, I think this is when we actually need to advance. And then again. So right, we advance. Right, and we need to check the current token again, something like this. But good thing is that now if we find token extern, what should we do? We should advance and return like extern. Export extern, I guess. Right, so it's like this. We take the current, then we advance if it's assigned, then we take the current again. If it's extern, we advance and return external expression. Otherwise we build expression, and on the else case, like if it's not an assign, if it's not initialized, we do expression null. And here we need to do expert. I guess expr is gonna be an expression node. Right, like this. And yeah, as I said, here is gonna be like build expression, but that's something else. I'm curious what the ref looks like. Okay, so it just shows the expression, and that kind of sucks, but it is what it is. I mean, you know, decent, let's say, because we are able to at least have attributes. I don't know why I placed it here. It should be maybe here above the attribute. It's more related to attribute. So yeah, now at least we have that. Let's see if it still runs. Yeah, it still runs, but if we were to run it on 0.3, oh, it's not gonna run because we don't build expression here, so we would need parse expression basically. So yeah, parse expr, something like this, and here we need to call to parse expression pretty much. But here comes the main issue. Because this is going to be hard. Right, I mean, at least we have a node int, integer, so at least we have that. Class expression int inherits expression node. Sure, it should have something on it. But here, for example, we can do something like, I don't even know, like it's oof. Because easiest thing would be case current. Like, let's try to hard code the token int, I think. And we do like expression int basically, and on any other case we do expression node. Sure, let me see something like this. And as I said, something cool would maybe be to have an init on expression int, and like a token type somehow, or I guess value. Let's say value token int, and then init is gonna be token int self type. Why not? Value is equal to v. So something like this, right? And now obviously show is something that needs to be on expression node. Whoa, an expression node. Let's say all it does is new IO. It doesn't do anything, but for expression int it should do something. Maybe something like, I don't even know. I mean, all it has to do is display its value. So let's see. Basically, we have token int. Right? Token int is just like any other token, though. So we do something like value.value, right? S string whatever. I don't think we need a new line. Yeah, whatever. I think it's an extra parenthesis. Okay, so this is how we show an expression of type int. And then something like if not is void expr, then expr.show indent plus 2, else like, I don't know, else 0. Okay, let's see. 5 to 6, 5 to 6. Okay. 7, 8, 9. Oh my god. 7, 8, 9. Funny. Okay, so here is 790. Holy shit. Okay. So I would imagine that something happened here, maybe. I really like debugging in this language. It's okay. So this one worked. That's pretty neat. Expression int maybe. Like in this one, maybe I can show that. Wow, I don't remember if I copied it. Huh. Okay, even here it works. Perfect. Then it means that we get an int expression, right? We get an int expression. But we don't really advance. So here, for example, we don't advance. I don't remember in build expression. I mean, I advanced sometimes. I guess it depends. But let's say that we could advance here. Huh. Oh. Well. And maybe have a let expression node in something like this. Yo, that's close. So I guess the other thing is to show a new line in case we have an expression. That makes sense. Literally new line. Okay. I mean, maybe without +2. Yeah, it looks fine, but here, why do we have a space? Oh, because, yeah. Because it's gonna be not void expression. Like worst case, it's gonna be a null expression, so I mean, it's still there regardless, right? Expression null. So then, not the best way to do it, but no, pretty close, I would say. So maybe here we could do like a case, but we still have to work on expression, so I don't see the point yet. So yeah, we'll see.